How are you going? How are you going? How art thou going? Anyway, welcome back to part 3 of our series. A lot of things have changed since last time and we're essentially starting all over again, but it's for the best, I promise. Since last time, I spent about 2 weeks digging up data on over 10,000 players based solely on mining spots in free-to-play worlds. Then I sent those over to Dr. Clint, who helped us to collect over 1 million data points of each player's historical high scores data. Lastly, we spoke to the wise and noble OSRS sage known as SirPugger, who revealed to us the incredible secrets of Old School Runescape's botting. With all our powers combined, we produced a model that is correct at least 99% of the time in predicting whether we have a bot in our presence. Now before I begin, I wanted to make the goal of this project clear. SirPugger, other than teaching us a bunch about what makes up a bot in OSRS and how to catch them, also enlightened us on what Jagex has going on behind the scenes for bot spotting. To the best of his knowledge, of course. He mentioned that the bots which get banned the quickest are those that use multiple or even hundreds of accounts at once, doing the exact same thing with each account, and Jagex is pretty good at picking up on those patterns. However, that can sometimes take days or weeks depending on how complex the bot is or how many are running at once. And that is a problem with a lot of real-world applications of traditional software. It works amazingly well, but sometimes only on very specific cases and fails to generalize to a larger scope or dataset. Which means Jagex has to go over each different botting case manually, and that takes a lot of time and resources. And that's where our project comes in, right? We aim to use machine learning to generalize the discovery and detection of these bots, or in our case at least the suicide bots, to show Jagex that new tech really is the way forward in terms of identifying complex patterns that will allow us to get faster and more accurate results, even on bots that we have not yet seen. Alright, let's dive into how we did it. So we ran that same data collection process for about a week, and we got a whole bunch of names, about 10,000 names in the end. And I sometimes accidentally left it overnight. I think it was like halfway through the process. Let me try and find a place here. But essentially what happened was, like right here. Got a bunch of people with really random names, right? There's just like 6 letters each for their names. Definitely doesn't make any sense, but there's a whole bunch of them. And I feel like that's the people we're probably going to be aiming for. And I also did something different this time where I collected their anything that they said throughout the data collection process, and I was supposed to give prompts like ask them if they're bots or whatever, but I feel like that was too invasive after having tried it out with some people, because everyone who gets that prompt answers, and even if they aren't bots, and it's kind of invasive for just their game playing process. But yeah, I have been collecting. It's not like many people would say things otherwise. Some people do say stuff though, and that's what's being collected. So that's kind of good, but also it doesn't happen that often. So either way, we end up with around 10,000 or so data points. So 10,000 different players all throughout the week that I was collecting it. And from that, we took all the data that we had collected ourselves and gave it to Dr. Clint, who then ran his own algorithm to get their high scores data over time. And he started on the 8th, which I think was maybe a few days after I had started, and he went on collecting for as long as, well, he's probably still collecting his data now. But yeah, so if we look at each of the usernames, there's around 500 entries per username, depending on if this person was in the data set for that long. I mean, if this person was available on high scores for that long. So some of them, are less than 500, some of them are 300, some of them are like 1 even. And he went on collecting all that data over time for how these people's high scores have changed. And he ended up collecting a crazy 1 million data points. And so not all of them are covered here. Not all of the names that I have gathered are covered here as well, and we'll go into that later on. But essentially, it's because that upon the time that he was running his algorithm, that they had already been off of high scores. So either they are banned or they weren't high enough level on high scores to begin with. But it seems like high scores is a pretty low bar if it's getting just at 60k EXP. And I'm sure you can find lower examples as well. Like I don't know. Well, I'm sure you can find lower examples, but essentially anything that doesn't show up here means that they don't show up on high scores for that particular skill as well. So they only show up for mining, for example. But a lot of them, do have other skills that they are pretty high level in, which is great. Yeah, and that's about it. That's what we collected. Alright, now it's time for the notebook, and after we got all the data that we gathered, it's time for us to explore the data, pre-process the data, and go through all the things about machine learning for it. And I went through a lot of this before, so I'm probably going to be skipping over here and there. But it's mainly about what we can do moving forward with the new data that we gathered, right? So yeah, all this is pretty much the same, just grabbing the same libraries, cleaning the same data that we had previously. So this is the data that I gathered, and we ended up not using this so much now because it wasn't very specific high scores. As you saw earlier, there's a bunch of zeros in it, and I think it was because the high scores data was down for like the whole week that I was gathering data. But what we do end up doing is explore Dr. Clint's data, right? It's a whole 1 million data points and 2,000 users tracked. So we grab that, put it into a little pandas data frame. We can see that we can get any user that we want. For example, Zurich, who has a ton of stats everywhere, right? And we just see how much is matching between our original and Dr. Clint's data set. And it turns out it's only about 1,900 names that go over from our original data set of 10,000 to Dr. Clint's. But that's not undermining Dr. Clint's work in any way. It's just the 8,000 names that were had probably just didn't end up in high scores, and that's I'd assume that they got banned, but we'd also be able to assume that they were too low level or too little time playing, that they weren't on high scores yet. Anyway, so when you're exploring the full data set, we noticed that there are a ton of people with over 500 data points. So that means they were fetched over 500 times. And everyone else is falling somewhere between 0 and 400. And this could mean that they got banned at some point in time when Dr. Clint was looking through and fetching their data from high scores. So that's, in my head, that was pretty indicative of, who is going to be banned, right? So if we look at one of the people down here, which we counted basically how many of them, how many occurrences they come up in with their data points. And I went for specifically less than 150 because I looked at some others that are above that and they seem fine. But everyone below here looked like someone that's, specifically training and mining. And that's all their training, and they get a lot of mining EXP over time, right? So in my first thought was like, okay, these are the people who got banned, and these are the people who only train on mining and got banned. So that's perfect, right? That's what we're looking for. But as you'll see later on, it's not something we stick to because, sometimes there's just one occurrence and maybe this person just doesn't log on after that at all, ever, or gets banned as well. But I don't know, for whatever reason, maybe high scores just fails, and I don't know, it's a flimsy system. Anyway, so we go back into feature engineering, right? This time we have a whole different kind of data set. This time we have a bunch of data over a series of time, as opposed to one data point per person where we just have their scores, right? So what we may need to do this time, I thought, was to aggregate all the scores, to put them all together, and to produce one data point per person and have an aggregate of all the different skills over time. So that's what we did, right? We took a bunch of different functions and crammed all of that into one thing. And we can do that simply by using pandas group by based on their username. And then we applied this function to aggregate all the different skills into max, means,
differences over time.
Okay, so a real quick rundown on the pandas group by function. We have a bunch of names like this in our data set, and each of the names represent a row of when we collected the data. So if you see this guy, Bill90 AI, and his mining increases by 10 every hour or so, let's just say we collected the data every hour or so, we want to group all the data points with his name in it into just one row where we say, this is the name, and we want to group it such that, we get the EXP per hour. So we saw there that his mining EXP was increasing by 10 every hour, and that's what we have. So for another example, we see Totoro here, who increases the mining by mining EXP by 10,000 every hour, and that's exactly what we want in our new data set. And another example, less data points, but still increasing by 42 every hour, and that's what we'll have. So notice that, the first compared to the last, right? Even if the first guy has more EXP overall, his EXP per hour could be lower, and the last guy has a much higher EXP per hour. And this is what we're looking for, right? Bots typically have a higher EXP per hour because they're just able to go for it and be as efficient as possible. But also notice that, Totoro, with a higher EXP as a whole, is able to get more EXP per hour, and that's a pattern we notice a lot because, as you go higher up in level, you also get to mine things that give you more EXP per hour in general. So it could just be that, as someone who's higher level, they get more EXP, and that's something that we'll take into account for sure as well.
So that worked really well, I think. Spent a bit of time on this, but it ended up getting us, how many rows they had, what number of relevant skills they had. So what were they training for over time? If there is one relevant skill, that means it's probably only mining. If they had 3 relevant skills, they were training, mining. In this case, it's fire making and fishing as well. So the number of relevant skills just depends on what they were doing over the period of time that we were collecting results on them for. Right. So the max is just how much mining EXP you got as at the end. The mining difference is the total max minus min over time, and the time is in hours, right? So this person with 167 rows, we collected data on them for 88 hours, and max minus min over this got the mining difference per hour. So this is how much EXP they got per hour, which is, I think, a lot, but up to some skillers, they probably don't think it's much at all. But yeah, so this is the difference over time, difference per hour, and this is their mean. So it shows them, it shows us how much EXP they kind of had to start with, probably. This is just their EXP average throughout the process. And we do the same for all of these things, right? We got the difference over time for all the skills and the mean as well for all the skills, just to see how much EXP they had in total for those skills. Okay, so now that we have everything in place, we went through some exploration of our own with unsupervised learning. And people think of all of machine learning either as like reinforcement learning or prediction, but there are a lot of good use cases for unsupervised learning. So unsupervised means not having a label to your data set. It's not like our data set currently has like bot, not bot, not bot, bot, or whatever. It is all unfiltered and just raw data that we have, right? So what we need to do is to try and explore our data set given this unsupervised method, so a method without labels, and seeing if we can find patterns on our own that we can use to later on label or even later on predict based on these different algorithms. So the first thing we use, and pretty much all that we use throughout this process, is called k-means clustering, and I'll put up a little visualization of this here. Hopefully I can find one. But essentially what it does is it splits the data set into as many clusters as you'd like. In my case, I'm splitting it to 4 clusters at first, and then we're just visualizing the data on a plane, either 2D or 3D, and I mean it can go up in dimensions, but whatever. And after you visualize this plane, you color them or you cluster them based on their similarity to each other. So without going too deep into the algorithm, it essentially starts out at 4 random points, and then it keeps they keep moving these points essentially little bit by little bit to get the best kind of clusters that you can get. So now that you know what k-means clustering kind of is, I try to do that at the start. I go in and I take our data set and I start with just the relevant skills, mining difference over time, row count and time difference. But what I take is relevant skills and mining difference. So what I want to kind of separate is that, okay, maybe if they have a lot of relevant skills, then they're probably not bots because they're doing many different things over time. And the mining difference. So if they have a lot of EXP difference per hour, then we're probably going to assume they're bots as well because they're so hyper focused, right? So I put that out, right? And okay, whoever the hell this is with 40k EXP over time, that's insane, right? But it didn't really tell us much. Everyone on this low tier, no matter if they had 0 or a lot of relevant skills, that they didn't get segmented out. The people who are up here obviously got segmented out, but there's only 3 people, and I don't think they account for most of their bots anyway, because if they got so much EXP to begin with, that could mean that they just weren't banned. And if they weren't banned and at a really high level to begin with, maybe they're not the suicide bots that we're looking for, because at really high levels you get more EXP per hour than you would at lower levels. You don't just keep mining iron for the rest of your life, right? You go up to different kinds of ores and you get more EXP for those. So this could be a really high skilling account, for example. So yeah, it didn't tell us much, right? So I tried to do different things. I tried to see if see who these people were who were getting 20k or more an hour, and this is who they were essentially. But yeah, and then I kind of tried to take out the outliers. So I took out all these people who had crazy amounts, which I believe are not bots to begin with. And I tried segmenting that out as well, and it didn't work too much either. So it still didn't care essentially about the relevant skills. So yeah, so I thought, okay, maybe I have to do something else. Maybe I started scaling. So scaling is where you don't let it go from 0 to 40,000 as opposed to -1 to 1, right? So this is the standard scaler, and it scales everything down. Essentially, it's just to not allow the algorithm to think that 40,000 is a huge number, I'm gonna go for that one, right? It's to scale it, and it's to show the algorithm that all of these values are the same. All of these skills, all the features that we're putting in have the same amount of weight. Not necessarily 40,000 is huge and just one relevant skill that I don't care about the number 1. So I try to do that, and then I also try to apply PCA, which is what's known as dimensionality reduction. For example, I have a bunch of features here, right? I have a bunch of features like row count, relevant skills, mining max, and all that. I tried to cram it all into 2, and that's not a good idea to start, but I think that idea is something that will help us a lot in the future, right? We tried to cram all these 31 columns into 2, and we tried to split that up. And okay, to be fair, it looks a lot more splittable, right? We can see here that whatever this column is, whatever this cluster is clearly different than this cluster, and that's great. But we don't exactly know what these 2 represent now, because once they are squished, we don't know how they got these different combinations to squish. Dimensionality reduction just squishes all your data and helps you to further split them up, right? And okay, so after we got things like this, right, it looks much more promising and separable, but it's less intuitive, like I say here. So we try to make more sense out of clusters. We, for example, take a cluster. We take a cluster and say, okay, what is this cluster? And then we look at the data ourselves to try and identify, what they might have meant. And looking at this data, right, every one of this is in cluster number 1. right? And every one of this is in cluster 0 and so on. So let's see what's in cluster 1. It looks like, huge high max, and the mining difference is, pretty high as well, right? And the relevant skills, so they're pretty focused too, right? 0 to 5. And then in cluster 0, it's completely no mining difference over time. So they're not mining at all. And I don't think we need to look at this to begin with. Cluster 3, high relevant skills, right? So we can see that, they are doing a lot over the time that we're collecting data on them. So they're probably not bots because they're going around like killing cows, they're going around mining, they're going around fishing. We don't care about these people as well. So I think we can make some pretty good assumptions to start on these people, right? Cluster 1 looks like kind of the people we're looking for in a way. They're huge mining, mining and max, and then they are low in relevant skills. But the more you think about it, the more it's hard to completely say that they are the ones that we're looking for. Firstly, they only have like 37 of these people, and also they do have other skills over time in random places, and maybe this could just be skilling bots. So in my head, I tried to go down a bunch of other random things. I tried to squish like less of the columns. I tried to, what is this? Okay, I don't really remember what I did, but I essentially kept trying to go down different paths of extracting that data, and I just couldn't do it with all of the data that we had, all 1900 names, because they just weren't splitting properly, or I wasn't satisfied with the results, right? So I have a whole Unsupervised Learning Part 2 where I scrap all of what we've done before, and we focus on those who have been mining to start. Yeah, so I choose to only look at those who have been mining in our data, as opposed to looking at all the bots at these mining spots. I'm looking at only the bots that we've collected data on who have been mining over time. And that, as you'll see, is much less than all the bots that have been collected. But yeah, so after all that mess, right, after throwing away all of what we had previously done, I decided to really hone in on the problem. So we're really focusing the project now purposely on suicide bots that have a lot of mining experience and are starting out just as bots and don't even care about whether they get banned or not. They're just going at it, right? And that's something we can try and identify more of. So what we start off with is we severely reduce the number of things that we're looking out for. So we don't care about all the other skills. All we care about is, how many relevant skills they have as a count, as opposed to, what their EXP was, what their difference over time was. But what we care about now is how much mining EXP they get over time, right? So the same things apply. It's the EXP per hour, how many hours that we collected of them, and their mining total. And so we tried to start out with that, right? We tried the same k-means clustering, and it looked something like this. I think this is what mining max over mining difference over time. So yeah, this kind of validates our assumption that, if your max is pretty high, you're pretty much getting a good amount over time as well, because you're probably mining tougher ores. But it doesn't tell us anything, right? This could be bots or noobs, and that doesn't help. So what we try to do is we make different kind of features. So the first thing I thought of was, okay, what if we could get the total mining over their max mining? What this would give us is, how in this process, in this span of time, how much has this person grown? And if it's 0.8 to 1, or this value essentially of the mining total over the max, that would mean that this person went from like level 1 to level 50 or something. But if it's low, this person could have just went from like level 50 to level 70. And those people are people that we probably don't think are bots, because they started out in our data set as someone who was high level to begin with and then just kept going slowly. And that's fine. I feel like, if you're a skilling account, you're probably like that. But if you started out at level 1 and you just kept going and going and going, that's probably who we deem as bots or skilling accounts. And you can see later on that we do identify the difference between skilling accounts too. And then there's also mining overall, which means how much mining EXP do you have over all the EXP that you've gained so far. And I think this is a pretty good one as well, because overall difference just shows how much EXP you got for all the different skills. So it just shows how focused are you on mining. If this is also like 0.8 to 1, we can say that this person is pretty damn focused on mining as opposed to like their overall skills, right? So yeah, let's see how this looks. Total mining over time. As you can see, it's like 0.94, and essentially it's just the total over max as it applies. But over the period of time that we were collecting, this person went from like 20k EXP to 290,000 EXP, right? And this is pretty hard, and I found out that there were a lot of infinities because the overall difference is 0. And what does that mean, right? Because I thought that the overall difference would be just a collection of all of the differences combined, but apparently it's not. Apparently I have to do it myself. I have to count all the differences myself, but I end up doing that anyway. So we first try it with that, right? We first try it with the mining difference. And well, what do we try it with? I think we do try it with the total over max versus the mining difference. And we get something like this. Not very clear, whatever. And then we try applying PCA, right? We try applying PCA to something that's a much smaller data set. We just keep total mining over max, we just keep mining difference and the other relevant skills. So we end up with something like this. We apply that PCA, and then we get something like this, which is our most promising result so far, right? So this is what clusters look like, I guess. And these aren't very separable to begin with because there's a lot of like overlap. But what the clusters gave us was something pretty promising, right? So if we look at the clusters ourselves, so this is cluster 0, right? Cluster 0 is, I don't know, one of these colors, and later on I go and color code them. But for now, cluster 0, very low mining over total difference, meaning that, they don't care about mining. They care about everything else that they're working on, and you can see their, relevant skills are pretty high as well. So yeah, pretty good. And then cluster 1, as you can see, lots of relevant skills. So these are people who are, doing everything. They don't care about mining. And, even if they did have a high total over max mining, meaning that, they went from 1 to 50 in mining, they don't care about that. They probably care about everything else as well, right? So these are probably people maybe starting out or starting their mining journeys, but have been training all the other things as well, which is good for them, right? And then we go to cluster number 2. And these are the people who we think, okay, maybe these are the bots, because they go, all of them are consistently high total over mining max, and a lot of them also have some pretty high mining over total difference. So, they're very focused on mining, and they're very focused on getting from 1 to 50 in mining. And their mining difference per hour is pretty insane, I think, for people who are just starting out mining, right? And their relevant skills are pretty low as well. So we think that this is a pretty good place to start, right? 134 samples of people who we think could be bots, right? And then there's also number 3. And this is kind of cool to me to think about, because I think these people are the people who are more like skilling accounts. And I'm thinking it's pretty cool to have found that, right? Because, okay, so these people are clearly ones that are focused on mining, with 1 to 5 relevant skills, which is, shows you how much they focus, because if they have 3 relevant skills and are 86% of the time focused on mining, then, they're pretty damn focused, right? But all the total over max mining is lower than like 0.6 or 0.5 most of the time. And that shows that they went from like level 50 to level 70, for example. And, I think this is pretty indicative of what skilling accounts are, because when they go from 0 to 50 is pretty easy, or pretty easy to make a bot for that. But to go from level 50 to 70 with a bot is pretty darn hard, right? You're pretty much expecting to get banned at that point if you're going gung-ho at mining and don't do anything else with your life. Okay, so now this is where Lugus suggested some really cool things that I tried out. So one of them was TSNE, and remember that PCA dimensionality reduction that we did earlier to squish all the things that we had into things that we could hopefully separate. This is a much better method, and I go ahead and apply it a bunch of times, right? And this is what comes out. And I do a lot more clusters this time because I realized that even with these 4 clusters, we got some pretty good results, but there were some inconsistencies too, right? There were some things that stood out that I didn't really think were good to have stuck out. So I split them into 10 clusters this time. And as you can see, even in a 2-dimension space, it's much more separable. So even, a baby could tell that this is clearly a different cluster than like something here or something here. So yeah, I think it worked pretty well. It was more separable. And then we went into each of the different clusters, right? And all right, I just give a little explanation here on how TSNE is better in most cases to separate things. But, who cares? You're not a nerd. Unless you are and you can read it. Okay, so clusters. I need to stop double clicking. All right. Clusters. The clusters ended up being like I described here. And I think, now that we have more fine-grained clusters, like 10 clusters as opposed to just 4, we can really see the difference in behavior. And this is what I thought was really cool, right? We can really identify who is playing and how they are playing, and split them by a certain user group. So this group could be like super hardcore Iron Man players, and these people could be like, well, maybe not so close to them, but these people could be like completely casual. I don't train anything, I'm just here to speak, right? And I thought that was insanely cool, and I feel like that's something that Jagex could get on. And that's something that has been brought up previously in one of their videos, I think, especially the one that SirPugger mentioned. But yeah, if they're doing that for behavioral prediction and identifying what a player is like, they should be pretty easily able to identify how different bots are from those players, right? So this is what we end up going for, right? We split them all up, and then I find out that cluster 8 is the one that's most likely to be bots. Just as we saw earlier, very high mining over max, very high mining over total difference, and very low relevance skills, right? And all of them have pretty much a shit ton of EXP that they're gaining. Clearly there's some outliers still, right? This one has 9 relevant skills, and we're not going to identify that as a bot anytime soon. But it's pretty good to start out with. There's also cluster 7, which is what happens, I guess, when you split it up too much. Sometimes there's overlap, right? This doesn't look very similar. Oh, okay. I think I know what's wrong. In Jupyter Notebooks, everything is sequential, and I had ran this all before, so full DF here is not the same full DF that I'm expecting. And let me just run this again just to further elaborate the point. But yeah, full DF is essentially something that I had defined below, which is not the right thing. But cluster 7 now, as you can see, is very close to our purpose. Very high focus on mining, very low relevant skills, but they may not have a very high total mining over max. And this is somewhere I think between the middle ground of where a bot stands and where a skilling person stands. But yeah, so 2, 4, 6, and whatever is people with very high relevant skills, as you can tell. So that's not the people we're looking for. 1 is high total mining over max, so they gain a lot of EXP over time, but they also have very high relevant skills, and also pretty low mining over total difference. So they're not just focused on mining, which is pretty cool. So these are the people who I think are hardcore, right? They're getting a lot of EXP over time, or like starting out to be hardcore. They're getting a lot of EXP in mining over time, but they're not just focused on that. They're focused on 4, 5, 6, 7 other skills, and they're putting equally as much of attention into those skills. And 0 and 9 is low in both. These are the people who I think are lazy, like myself, by the way, and just not doing anything, right? They're not focused on mining, but they're also not getting much in mining, and they have a lot of relevant skills. They have, but yeah, cool people. Just at a chat, right? And yeah, that's essentially it for unsupervised learning. Everything below is kind of like testing different hypotheses regarding TSNE with like higher dimensions. So not just the 4 that we started out with. We try it with 27, we try it with 57 as well, and this gets a jumbled mess, so I'm not going to go over it, but what we stick with is these 4, and I think they were pretty good. So now we go into supervised learning, and having gone through all that previous searching, we now know what kind of cluster we want to be searching for, right? So we start with cluster number 8. Yeah, and now that I'm looking at it, I could start with both cluster 8 and 7, which is wild. Maybe I will do that, right? But essentially what we do is we label them ourselves, right? We label 0s and 1s on people who we think are bots, and then we go to normal supervised learning methods, things that you may have heard of before, like logistic regression or random forest classification. And I kept going down that route and finding out ways to keep the accuracy higher and higher, and we got to some pretty darn good accuracy scores. So like in this case our accuracy is 99%, and in this case our accuracy is 99% too. Yeah, and then we tried it with some other stuff too, which I don't think that really matters. What? Okay, no, something's up here. For whatever reason, there's only 2 things in bots versus not bots, and that is not right. Okay, so the random state is the same. What? Oh wait. Okay, give me a second. I'm gonna try to increase the number of clusters we can get. Full def is the same, maybe full def is from here, which is all right. We want it to be from these people, right? What is right on the results? So where's full def here? Okay, maybe then. We save this as right, it's full def, not copy. I'm going to save this, maybe safe with Jupyter. Not surprising. It's not full def. It is for both, right? Okay, maybe label 0 for all the others. Sure, but Jupyter is okay. Do this. Okay. This not this one. It's not 7 and it's not 8. Alright, okay, 134. I think that's right. Okay. Label 0 for all others. Get down, combine them. And then we split. Okay. Still 265. Great. 15, which is good. That's better. And yeah, okay. Okay, what a process, right? Okay, so yeah, we essentially get 15 out of the 265 for people who we think are bots. And remember, when we're splitting it out, right, we're getting 30% of our total data set, which is around 800 people, to be people for testing. So these people, this 250 and 15 players and bots, are just part of the testing group. So things that our algorithm has not seen before. Okay, good that that's cleared up. That would have been a mess. Anyway, so now that we get that done as well, this can give us our important features. So it tells us, what is important to look out for among the things that we gave them in features. So in here we have 0.4, which is pretty high. So they're saying total max over mining, and you'll see later that they say mining over total difference is also pretty high. And that's just because, we labeled them ourselves and we thought those were important. So they kind of just tell you more of what they think is important. And this will be helpful, I guess, in more real use cases where, you have labels and you don't really understand how to effectively choose what's the most important. Anyway, now that we have an algorithm which is nearly 100% correct, despite they're having very low data points. So, it's something I'm looking out for as well. We have very little data, and I understand that, and we're using purposely less complex models, not like a LSTM or any kind of those things, any of those kind of things, because it is such a low amount of data, and we're trying to avoid overfitting by using a simpler model essentially. But yeah, so now that we have these models that we want, I go ahead and save them as the finalized model, which in later time, as you can see here, we'll just use by loading the model and predicting with that model and getting the exact same result. Yeah, so that's what we're gonna do. All right. Yeah, that's it pretty much for this video. We went through all the steps of preprocessing, feature engineering, and unsupervised learning just to get just to easily get the players that we wanted to classify as bots. We labeled them ourselves, and then we went ahead and applied supervised learning techniques to predict if this person is a bot or not bot, to produce in the next video our final bot that goes around and bans bots. Alright, that's all for now, folks. The last thing to do for this project is to make a bot to classify these bots in real time and report them in-game to jagex. Like I mentioned in the start, we only focus on mining suicide bots here, but I think it's clear that with more work put into it, like, I don't know, with someone's full-time job, that this could be very useful in the long run. Not only will it be able to much more quickly detect bots as they come in, so in much less time than a day, but it'll be possible to predict future bots regardless of their little quirks like randomized movements and all that. Furthermore, we're hyper-focused in our project only because we have to be. If we had data like what jagex has, the clicking patterns, login times, etc., plus the pre-labeled data that they easily have access to with all their past bans, the model could be so much more powerful because it knows all the bots that they've identified in the past and are able to potentially generalize to any new ones that come along the same lines. Human behavior is a very specific and pretty separable thing in most cases, and I hope to have shown that here. You could argue that bots have gotten a lot better, and some are even mimicking the actions of real life players. So I guess it's more of a philosophical question at that point for the developers if these bots are truly inseparable. Are they a problem to begin with, or would it just make the world feel more filled and alive? But enough of the complaints on my side. Let's talk about how we, the plebs in this case, can do better without the almighty jagex's data, right? If you've been paying attention, there really is a lot that we can do to improve on this current project. I'll list a few here just for sanity's sake. We could do a further analysis of the names, like the incredibly obvious ones that we found, which were most likely banned before we even got to them on high scores. Or looking into their equipment, getting better data by prodding them with the questions and seeing if they respond at all. Anyway, I'm pretty proud of the results we've been able to achieve so far, and I hope that this is a good enough proof of concept to start for anyone at jagex to realize that behavioral prediction or machine learning applications in general are super simple and can produce amazingly automated results if you put in some thought. So hey jagex, if you're watching this and need some advice, please reach out and I'll be happy to help for a measly price of an old school bond. Now before I end, I wanted to bring up this book that I've been reading called Building ML-Powered Applications. It doesn't just go over the typical stages of the process or cover the technical details of models much at all, but it instead goes deep into how you can properly build production-ready ML applications. It dives into framing the ML problem, debugging models, producing well-structured pipelines, and most importantly for me, deployment and the many phases it involves. And I'm seriously kicking myself in the butt as I realize how much better or how streamlined this process would have been if I had read this book sooner or before the project started. Anyway, that's it. I highly recommend it if you're into applied ML AI as much as I am. Alright, video over. Thanks y'all. See you in the next one.